Hi guys, I want to show you a quick video on how to predict ionic compounds, predict how elements are going to interact and how they're going to create different types of compounds, okay? So I have in front of me the periodic table. That's going to become really important for us in a bit, but I really just want to open a sketch pad right now. So remember, ionic compounds are metals and non-metals, okay? So did mine? I guess my webcam just sits there. Okay. All right. I'll probably put that away in a second. Remember, ionic compounds are a metal and a non-metal. So let's work with just a quick example here. NaCl, sodium chloride, table salt, our friend. And let's remind ourselves what those Lewis structures look like. Remember those? They're coming back to haunt you. So sodium, it has one valence electron. Chlorine has 1, 2, 3, 4, 5, 6, 7. In our previous unit, when we would decide how compounds would interact, we would say, okay, this is ionic, I got a metal and a non-metal, this guy right here is going to transfer over here, and I'm going to be left with NaCl, and because I only need one of each, and everybody's fat and happy. Great. But that's actually kind of a lot of thought process, especially when you get to really more complex compounds, those involving polyatomic ions and things like that. So I'm going to show you the fast way, and you're going to be mad that I hadn't shown you before. So we know, let's erase this. We know NaCl, we know one valence electrons and valence electrons. And we also know that, I have to make my camera go away. I can't see myself. Bye! This is why I shouldn't film at the end of the day. Okay, so sodium has one valence, chlorine has 7. We know that when sodium is ionized, when it is happy, it has transferred that electron away and it is in a plus. Remember, giving things away is a good thing, so we end up with a positive charge. Chlorine would have to steal an electron to be happy, so it'd be Cl minus. Remember that if there's just a plus sign, that means it has a charge of 1, positive 1, or if it's just minus, it's a charge of 1, negative 1. Okay. All I have to do is make my compound neutral. So if I take positive 1 and I add it to negative 1, then it's going to equal 0, and that's why NaCl works so beautifully. But what if it's not so easy? Let's pick some new elements. So let's pick calcium and phosphorus. Calcium and phosphorus. So when I look at my periodic table, I see calculus here is calcium. Element 20 is in the second group, so that means it has 2 valence electrons, and phosphorus is in group 15, which means it has 5 valence electrons. So let's draw it out. Calcium and phosphorus. Calcium has 2. Phosphorus has 5. 1, 2, 3, 4, 5. In our last unit, we would have transferred away. And we would have said, okay, this guy goes here, this guy goes here. Now calcium's happy, but phosphorus is not. Better add another calcium, 2 more. Okay, that goes here, but now calcium isn't happy, so we got to have another phosphorus, and we would keep going and going and going. So let's do the simple method. Calcium, 2, phosphorus has 1, 2, 3, 4, 5. So that means if calcium becomes ionized and it is happy, we have to get rid of both electrons. So we're going to be left with Ca2+. We gave away 2 electrons to become happy. So, and we're going to have those full shells. So we're going to have charge of 2+. Phosphorus needs 3 electrons to be happy. An empty space here, empty space here, empty space here. So that means it will have to steal 3 electrons in order to be happy, so it's going to have a charge of 3-. Feeling familiar? Okay, so if I have 1 calcium and 1 phosphorus, that means I'm going to have a charge of 2+, and then 3 minus, if I add those together, that's going to be -1. That's not 0. Okay, let's add another calcium, another 2 plus. So that means I'll have 4 minus 3. 4 minus 3, that's going to be a +1. That's not good. Add another phosphorus. So we've got 2 plus 2 plus 2 plus, oops, add another calcium, I guess. And then for phosphorus, if I do 3 minus 3 minus, then if I add all of these together, 2 plus 2 plus 2 is 6. 3 minus 3 is -6. So that means I will have 6 minus 6, which equals 0, which means I need 3 calciums and 2 phosphoruses. Hey, you see how this charge was 2 and now there's a 2 here? And this charge was a -3, now it's a 3 here? All you do is crisscross the charges. Okay, let me show you again. Let's pick another one. Let's do something funny. Let's do iron 3. Okay, we'll do iron 3. The reason I'm saying 3 is because it's going to have 3 valence electrons. Let's do iron 3 and bromine. Okay, so iron 3, erase all this jazz. Erase. Iron 3 and bromine. If I draw a Lewis structure for these guys, we'll add them together, then let's change color for that. I'm going to have 1, 2, 3 valence versus bromine is going to have 1, 2, 3, 4, 5, 6, 7. So that means bromine is going to have a charge of -1 because it only needs 1 more to be happy. And iron 3, when you have the parentheses and the Roman numerals, it's literally telling you how many valence electrons it has. And since it has 3, that means it's going to have to get rid of 3 to be happy, and it will have a charge of 3 plus. Okay, if I have 1 iron and 1 bromine, and I add those together, then I'm going to end up with a charge of +2. That's no good. What if I have 2 bromines? Then that's going to be 3 plus -1 plus a -1. So that's going to be, we still have a +1. So let's add another bromine. Fe plus Br plus Br plus Br. So that's 3 minus 1 minus 1 minus 1. Hey, that is equal to 0. So that meant we needed 3 bromines. And look, the charge of iron 3 is 3 plus. We only needed 1 iron. I didn't end up putting a subscript here. So that means I only have 1 of that type of atom. That's all you have to do. So our final answer is just FeBr3. Okay, great. Something that might be handy for you to do is have a paper periodic table, or maybe you can alter a digital periodic table like I'm about to, and write your charges that you expect everything to be at the top of your column. So I know that everything in that first column only needs need to get rid of 1 electron to be happy, so it'll have a charge of +1. +2, I have to get rid of 2 for the second column. +3, plus or -4 over group 14, -3, -2, -1 for the following group. So remember, like nitrogen needs to steal 3 to be happy, that's why it's -3. Oxygen needs to steal 2 to be happy, that's why it's -2. And fluorine needs to steal 1 to be happy, that's why it's a -1. Okay, that's pretty much it. That's the entire process. I hope this has been helpful. I hope I talked about everything I needed to. See y'all later.